The module is module 5, but STP it stands for spanning tree protocol. So, like I said, this protocol it's very useful in preventing the frame loops on the network. Actually, switched network, not on every network. That network that has so many redundant switches and redundant links. An example, for example, if you have two switches like this, these are two switches with two links. Here we expect to have the redundant link. So one of the link, it has to be locked. So that we have one primary or one active link that every time this switch 1 wants to communicate with switch 2, it has to use link 1. Then link 2, it's a backup. Okay, it's a backup. And then when, in case, let's say this one here it's faulty, it has any issue, it's down, then this one here, it will automatically come up because it will be serving as a backup. But when the active is down, then the backup, it takes over. So the topics to cover: purpose of STP, and of course at least I've summarized STP operations and then evolution of STP. So the purpose, with this topic, it covers the causes of the loops in layer 2. Layer 2 network, and then still explains how spanning tree protocol works. Redundancy, when it comes to redundancy, it is very, very important when it comes to the what we call the hierarchical design. So it eliminates, with the redundancy, it eliminates single point of failure. That if you have the other door, and that door maybe you mispressed the key, and you have the key for this other door, you will use this door. You see that? So it is very redundant on your network, and even when you're designing a network, you make sure that you have those points of redundancy. You guys, so in case the door is down, maybe it's inaccessible, then automatically you can use a redundant link where you have access. So it's a must for you to have a redundant link. Make sure that you have those extra physical and then extra logical path. So Ethernet network may cause both what you call the physical and then the logical layer 2 loops. Logical and then the physical. So Ethernet LAN requires loop-free topology with a single pass between the two devices. So every time you have, because that is what I started with, because the buses having two doors, the back of those buses calling it emergency, and yet in reality you cannot use that door that very moment. But need, of course, they will break that glass and it acts as redundant or an emergency door. So a loop in an Ethernet LAN can cause what you call continued propagation of Ethernet frames until a link is disabled and breaks the loop. So once there is a redundant link which is open and active, then automatically it's going to cause what we call continuous loop. That's sendless. Sendless frames on the network. So we have an example of switched network. As you can see, switch 1, switch 2, switch 3. And one of the link is locked. So that the frame is not allowed to keep rotating on the network. Because every time, as long as it's from the other switch, this switch is going to accept it. Even if the other one was the source, with this, without STP, once the message rotates and goes back to the sending switch, that switch, it will treat it as a new, because it's from different. That is the message that I gave you, the scenario that I gave, the case that I shared with you guys. That it's the same message to the same person, but from different. I've sent so many people. Right? Tell so and so this and this. The other one also is going to deliver the message. So that person is not going to actually ignore the other message because it's from someone else. Okay. So you're not going to tell that person, hey, but yesterday you were here and you delivered the same message. No, because it's from someone else. So here is our network. Spanning tree protocol is a loop prevention network protocol that allows redundancy while creating loop-free layer 2 topology. So it has to make sure that the loops are prevented, they are not allowed on the network. So STP compensates the failure in a network by recalculating and opening up previous blocked code. So now look at this, the redundant link in the previous, as you can see, it is blocked. But in case, let's say there is a link failure, then now the X, it indicates that that link, it has issues. Now the other one which was blocked, not disabled, it's going to be recalculated and then it's added back on the code, and then it's being framed, the frames. So the issues with redundant switch links, the passive redundancy provides the multiple network service by eliminating the possibility of single point of failure. When multiple paths exist between two devices on an Ethernet network, then there is no spanning tree implementation on a switch. A layer 2 loop is going to take place. So layer 2 loop can result in what you call MAC address table instability, then link saturation, then we have high CPU. I talked about high CPU utilization because those many messages sent, they have to be processed. They have to be processed, meaning that those messages are going to occupy the CPU, make the CPU all the time busy. And then end devices still the same, which they will be doing the same, then resulting in network becoming unstable. So the message, for example, when it comes to address, MAC address, layer 2 Ethernet, it does not include a mechanism to recognize and eliminate the endless looping frame. So both IPv4 and IPv6, for them they include that mechanism to stop packets, to prevent packets from rotating, the endless rotation of the packets on the network. Because with IP headers, for them they have what you call time to live or hope live. Time to live or hope limit. That every time a package passes through a router, the hope limit it is that field it is reduced by a value, and the moment that value, the time to live or hope limit is decremented to 0, then that packet it is dropped. So there is a mechanism there on layer 3, but on layer 2 it's not there. So what helps on layer 2, it's with the help of the STP. That STP it will block the redundant link so that the passes just want one primary route on the switched network. Every time there is a need that you want to access the other room, and we have two doors, we have a redundant door which is in the corner, the other one, and then the main door is this. So every time you want to access the other room, you are not going to use the redundant link, the backup link, because for it is closed to where you need to access. No, you have to use the primary route or the active route at that moment. So without STP enabled, layer 2 loops can form, causing broadcast, multicast, unicast, and multicast and unknown unicast frame to loop endlessly. So this can bring down a network very quickly in just seconds, because the switch is going to keep on switching those same messages, rotating on the 3 switches, and each message that is received is treated as a different message. So when a loop occurs, the MAC address table on a switch will constantly change with the updates from the broadcast message. So with the results in MAC address, which results in MAC address instability, and this can cause high CPU utilization, which makes the switch unable to forward frame. So most of the time, still, when it comes to security, the hackers, attackers, the slate actors, they use that opportunity to create those loops on the network so that your network or the MAC address table is full. And once it's full, then automatically the switch it want to get that opportunity to check where is it from and where is it heading. So every time it comes, then it will allow it, flood it out, because there is no space. Because the space, it allows the switch to check and then store. Now that there is no space, how are you going to check? Are you going to check? So it will just allow it to go to the other devices that are connected, and then that it creates a loop or an opportunity of those late actors to gain access or to start collecting information on how to attack the network. So an unknown unicast frame is when a switch does not have the destination. Unknown unicast frame, that the switch doesn't know the MAC address of the destination device. So if it doesn't know the MAC address of the destination, so it will populate, it will flood that frame to all the available or active interfaces, so that the known or the targeted, because if the MAC address of the destination is unknown, then we know the IP address, or the IP address of the destination is known. Okay, it is known. An example I can give right now, flooding, the message is for entire network. Okay, so the MAC address, it is broadcast. So everyone will look at the MAC, oh, I'm the destination. But now after receiving it, it's going to allow or to move to the other layer, the upper layer, which is network layer. What's the IP address in the frame? Now the IP address in the frame is for specific device. That is Alan. We are looking for Alan. Okay. So now in the network layer, the stated IP address, it has to be compared. The IP address in the frame or in the packet with the IP address assigned on that very interface, on that computer, are they matching? Are you called Alan? Is your name Alan? So if you are not, then you're going to drop the message. Okay? And if your name is Alan, then automatically you're going to accept and then reply. So it will be on that machine to reply. And the moment it replies, then its MAC address, it's going to be captured. Yeah? So a broadcast storm, is abnormal high number of broadcasts overwhelming the network during specific moment of time. So broadcast storm can disable the network within seconds, just within seconds, not minutes, just seconds, by overwhelming switches and then end device. So broadcast storm can be caused by hardware problems such as faulty network interface card or NIC, or from layer 2 loops. Layer 2 loops. So if the network interface card is faulty, then it's going to be generating unnecessary flames. unnecessary messages on the network. And then even when there is what we call the loops on the network, loops on the network. So layer 2 broadcast in a network such as ARP requests are very common, and layer 2 malcasts are typically forwarded the same way as the broadcast by the switch. So the malcast and then the broadcast in the same family, they use the same mechanism. So IPv6 packets are never forwarded as layer 2 broadcast. So they are sent as ICP version 6 neighbor discovery. Because still, when it comes to IPv6, there is no broadcast mechanism. So a host port in layer 2 loop is not accessible to other hosts on the network. So additionally, due to constant changes in its MAC address table, so the switch doesn't know out of which port to forward a unicast, to forward the unicast frame. Because now with loops on the network, then a unicast method, it's not going to work. It won't work. Because with a unicast, it has to deal with a specific port. See? But now you have so many, it's like you want to access the other room and you have like 3 doors. You're going to bet now. Should I use this or this? Or the other one? So to prevent these issues from occurring in redundant network, some type of spanning tree must be enabled on a switch. So by default, spanning tree protocol is enabled. The moment you disable it, expect problems, issues. So the spanning tree algorithm is based on, the STP is based on algorithm invented by what we call Radial Perlman while working for Digital Equipment Corporation. So it was published a long time ago in 1985, those papers. So it's an algorithm for distributed computation of spanning tree in extended LAN. So the extended LAN, this is where you have a switch connected to another switch, and then at the end of the day, you need what we call the redundant link. See? You can have it in this format. It's not a must that it has to be this. It's not a must that it has to be this, like this. But there are those scenarios where you have a switch and then a switch. You see this. So this is an expanded network, LAN network. That you have switch 1, you want to connect it to switch 2. But what if one of this link goes down and then you come up with a redundant link? But if this one here goes down, maybe you have the backup. But we don't want 2 links to serve at the same time. So it has to be one at a time. Okay? So STP here is needed. Still, there is another, actually it's the next module, Ethernet, the Ether channels. That your target is just to increase on the speed between the switches. Because remember, this switch here, if you have these computers and then this, maybe you have a link here to internet. See this, to internet. So for these computers here and then the internet, ideally the speed here, you need to make sure that it's different from this. Because all these computers that you're seeing, the time maybe all the 20 computers to access internet, they have to share a link. Have to share a link to internet. All the 20 computers, they want to exit this network to internet. So that link is going to be shared. Like right now, there is no competition. But if I tell you, please, all of you out, meaning that you're going to share that door, you're going to compete for that door. So that door, it has to be big enough that at that moment when you want to exit the room, all of you want at simultaneously, you can use the door. Okay? So in case, let's say the link that you have, the ports that you have here, they're the same here. What do? We can go with what you call ether channels to increase on the speed. That if it's 100 per port and now you have 2, then it will be 200 MB per second. So there is a difference between now this one here and then this, the link in between. So in between the speed, it's going to be a bit fast, but that is the next, in the next module. So how does what we call STP algorithm create loop-free topology? How it creates a loop-free topology. The steps are there. Selecting a root bridge, there must be a root bridge. The root bridge is like a center. The root bridge is like a reference. The root bridge is like a class representative. That anytime you have a challenge, you're not going to go to a group and start communicating. You get it? There are those groups that are restricted. If you have the issue, please reach the administrator privately. And if there is a need to communicate to the entire group, the administrator will go to the group and then delivers the message concerning to the query that you posed, but not in the group. For you, posed the question outside the group. Now the administrator is the one to broadcast it. So here is the same. That in case, let's say there is a challenge on a switched network, those challenges, they have to be communicated to the root bridge. Now it's the root bridge to communicate the issue to all these other switches, to avoid those unnecessary messages on the network. While in class here, the other one is holding this discussion there, the other one, the discussion the other side. You say that, what is going to happen in the class? Be like you getting grasshoppers in one container. Have you ever tested that? You guys, your city bonds, your city bonds. The blocked link, we have a blocked redundant path. STP ensures that there is only one logical path. One logical path. For you to move out right now, you get through that door, then the other one, and there are those stated doors. But there are other doors that are blocked. You're not going to use them, but there is one logical path. So if you're to move outside this building, we expect you to exit using the main door down, ground floor. So it intentionally blocks the redundant paths that could cause a loop. When a port is blocked, then user data is prevented from entering or leaving from that. You're not going to demand, hey, please, there is a door here, I want to pass through this. Who are you? Maybe break that door and use it, but there is the other one, use the other one. So create a loop-free topology. Blocked port has the effect of making the link non-forwarding link between the two switches. So this creates a topology, where each switch has only a single path, only a single path to the root bridge. There will be a single path to the root bridge, similar to branches on a tree. You see that? Similar to branches on the tree. So you guys, trees, that there is always a main, it's called what? A main stem, and all the branches, they are attached to the main stem, isn't it? You will never find a branch who is actually true that it is attached twice on the stem. If it's there, then that is abnormality, and maybe you can see that there is here and then this, and it connects one branch. You get it? So they are trying to give us a scenario that can actually help us to absorb the concept. Then recalculate in case of a link failure, that the blocked one, if the main, that single logical link, primary link, one of the link goes down, then automatically they are going to negotiate. Then the blocked one, it's going to come up. The example that I gave you, it has to be blocked, not to allow the loops on that. Then creating loop-free topology. Now the blocked port, it is just placed in what we call non-redundant, non-forwarding link. It's not blocked. And then in case, let's say the main door there, it's locked now, this other one can actually be acted on and then use that by recalculating the case, recalculating in case of a link fail. When the link fails, that is when you think of the redundant link. So please always use the videos in your account, even the packet tracer, just they will guide you. It's not activated. Oh, okay. I think now this time